Every person morning. In previous class, we have discussed on the topic of interrupt controller. In today's class, we can discuss on the topic of 8279 programmable keyboard or display controller. Whereas 8279 programmable keyboard display controller is designed by Intel that interface a keyboard with the CPU. The keyboard first scan the keyboard and identifies if any key has been pressed. It then sends the relative response of the pressed key to the CPU and vice versa. How many ways the keyboard is interfaced with the CPU? The keyboard can be interfaced either in the interrupt or the hold mode. In the interrupt mode, the processor is requested service only if any key is pressed. Otherwise, the CPU will continue with its main task. In the hold mode, the CPU periodically reads an internal flag of 8279 to check whether any key is pressed or not with key pressure. How does 8279 keyboard work? The keyboard consists of maximum 64 keys which are interfaced with the CPU by using the key codes. These key codes are debounced and stored in an 8-byte FIFO RAM which can be accessed by the CPU. If more than 8 characters are entered in the FIFO, then it means more than 8 keys are pressed at a time. This is when the overrun status is set. If a FIFO contains a valid key enter, then the CPU is interrupted in an interrupt mode, else the CPU checks the status in the polling to read the entry. Once the CPU reads a key entry, then FIFO is updated and the key entry is pushed out of the FIFO to generate space for new entries. And the block diagram of the 8279 programmable keyboard display controller, it consists of a display address register and a display RAM, control and timing register and a FIFO RAM, keyboard debounce controller, data buffer and input-output controller and RAM status, FIFO RAM status, display register, timing and controller and scan counter and return, followed by the input-output controller. We can discuss on the block diagram. The I/O controller and data buffer. This unit controls the flow of data through the microprocessor. It is enabled only when D is low. Its data buffer interfaces the external bus of the system with the internal bus of the microprocessor. The pins AO, RD and read and write are used for command, status or data read or write operations. Control and timing register and timing controller. This unit contains register to store the keyboard display modes and the operations as programmed by the CPU. The timing and control unit handles the timings for the operation of the circuit. Whereas the scan counter, it has two modes, that is encoded mode and decoded mode. In encoded mode, the counter provides the binary count that is to be externally decoded to provide the scan lines for the keyboard and the display. In the decoded scan mode, the counter internally decodes the least significant 2 bits and provides a decoded 1 out of 4 scan on SL0 to SL3. That scan counter 0 to scan counter 4. It is a 4-bit counter. Whereas in return buffers and the debounce control, this unit first scans the key closure row wise. If found, then the keyboard debounce unit debounces the key entry. If the key, in case the same key is detected, then the code of that key is directly transferred to the sensor RAM along with shift and control key status. In FIFO sensor RAM and status logic, this unit acts as an 8-byte first in row first out, that is FIFO RAM, where the key code of every pressed key is entered in the RAM as per their sequence. The status logic generates an interrupt request after each first in first out read operation till the FIFO gets empty. In the scanned sensor matrix mode, this unit acts as a sensor RAM, where each row is loaded with the status of their corresponding row of sensor into the matrix. When the sensor changes its state, the IRQ line changes to high and interrupts the CPU. Whereas in the display address register, this unit consists of display address register, which holds the addresses of the word currently read or written by the CPU to or from the display RAM. Thank you.